HTTP cookies are small blocks of data created by a web server while a user is browsing a website and placed on the user's computer or other device by the user's web browser. Cookies are placed on the device used to access a website, and more than one cookie may be placed on a user's device during a session. Cookies serve useful and sometimes essential functions on the web. They enable web servers to store stateful information on the user's device or to track the user's browsing activity. They can also be used to save for subsequent use information that the user previously entered into form fields, such as names, addresses, passwords, and payment card numbers. Authentication cookies are commonly used by web servers to authenticate that a user is logged in, and with which account they are logged in. Without the cookie, users would need to authenticate themselves by logging in on each page containing sensitive information that they wish to access. The security of an authentication cookie generally depends on the security of the issuing website and the user's web browser, and on whether the cookie data is encrypted. Security vulnerabilities may allow a cookie's data to be read by an attacker, used to gain access to user data, or used to gain access to the website to which the cookie belongs. Tracking cookies, and especially third-party tracking cookies, are commonly used as ways to compile long-term records of individuals' browsing histories, a potential privacy concern that prompted European and US lawmakers to take action in 2011. European law requires that all websites targeting European Union member states gain informed consent from users before storing non-essential cookies on their device. Background. Origin of the name. The term cookie was coined by web browser programmer Lou Montulli. It was derived from the term magic cookie, which is a packet of data a program receives and sends back unchanged, used by Unix programmers. The term magic cookie itself derives from the fortune cookie, which is a cookie with an embedded message. History. Magic cookies were already used in computing when computer programmer Lou Montulli had the idea of using them in web communications in June 1994. At the time, he was an employee of Netscape Communications, which was developing an e-commerce application for MCI. Vint Cerf and John Clenson represented MCI in technical discussions with Netscape Communications. MCI did not want its servers to have to retain partial transaction states, which led them to ask Netscape to find a way to store that state in each user's computer instead. Cookies provided a solution to the problem of reliably implementing a virtual shopping cart. Together with John Gianandrea, Montulli wrote the initial Netscape cookie specification the same year. Version 0.9 beta of Mosaic Netscape, released on October 13, 1994, supported cookies. The first use of cookies was checking whether visitors to the Netscape website had already visited the site. Montulli applied for a patent for the cookie technology in 1995, which was granted in 1998. Support for cookies was integrated with Internet Explorer in version 2, released in October 1995. The introduction of cookies was not widely known to the public at the time. In particular, cookies were accepted by default, and users were not notified of their presence. The public learned about cookies after the Financial Times published an article about them on February 12, 1996. In the same year, cookies received a lot of media attention, especially because of potential privacy implications. Cookies were discussed in 2 U.S. Federal Trade Commission hearings in 1996 and 1997. The development of the formal cookie specifications was already ongoing. In particular, the first discussions about a formal specification started in April 1995 on the www Talk mailing list. A special working group within the Internet Engineering Task Force was formed. 2 alternative proposals for introducing state in HTTP transactions had been proposed by Brian Behlendorf and David Crystal respectively. But the group, headed by Crystal himself and Lou Montulli, soon decided to use the Netscape specification as a starting point. In February 1996, the working group identified third-party cookies as a considerable privacy threat. The specification produced by the group was eventually published as RFC 2109 in February 1997. It specifies that third-party cookies were either not allowed at all, or at least not enabled by default. At this time, advertising companies were already using third-party cookies. The recommendation about third-party cookies of RFC 2109 was not followed by Netscape and Internet Explorer. RFC 2109 was superseded by RFC 2965 in October 2000. RFC 2965 added a setCookie2 header field, which informally came to be called RFC 2965 style cookies as opposed to the original setCookie header field which was called Netscape style cookies. setCookie2 was seldom used, however, and was deprecated in RFC 6265 in April 2011, which was written as a definitive specification for cookies as used in the real world. No modern browser recognizes the setCookie2 header field. Terminology. Session cookie. A session cookie exists only in temporary memory while the user navigates a website. Session cookies expire or are deleted when the user closes the web browser. Session cookies are identified by the browser by the absence of an expiration date assigned to them. Persistent cookie. A persistent cookie expires at a specific date or after a specific length of time. For the persistent cookie's lifespan set by its creator, its information will be transmitted to the server every time the user visits the website that it belongs to, or every time the user views a resource belonging to that website from another website. For this reason, persistent cookies are sometimes referred to as tracking cookies because they can be used by advertisers to record information about a user's web browsing habits over an extended period of time. Persistent cookies are also used for reasons such as keeping users logged into their accounts on websites, to avoid re-entering login credentials at every visit. Secure cookie. A secure cookie can only be transmitted over an encrypted connection. They cannot be transmitted over unencrypted connections. This makes the cookie less likely to be exposed to cookie theft via eavesdropping. A cookie is made secure by adding the secure flag to the cookie. HTTP-only cookie. An HTTP-only cookie cannot be accessed by client-side APIs, such as JavaScript. This restriction eliminates the threat of cookie theft via cross-site scripting. However, the cookie remains vulnerable to cross-site tracing and cross-site request forgery attacks. A cookie is given this characteristic by adding the HTTP-only flag to the cookie. Same-site cookie. In 2016, Google Chrome version 51 introduced a new kind of cookie with attribute same-site. The attribute same-site can have a value of strict, lax, or none. With attribute same-site equals strict, the browsers would only send cookies to a target domain that is the same as the origin domain. This would effectively mitigate cross-site request forgery attacks. With same-site equals lax, browsers would send cookies with requests to a target domain even it is different from the origin domain, but only for safe requests such as GET and not third-party cookies. Attribute same-site equals none would allow third-party cookies. However, most browsers require secure attribute on same-site equals none cookies. The same-site cookie is incorporated into a new RFC Draft 4 Cookies, HTTP state management mechanism to update RFC 6265. Chrome, Firefox, Microsoft Edge all started to support same-site cookies. The key of rollout is the treatment of existing cookies without the same-site attribute defined. Chrome has been treating those existing cookies as if same-site equals none. This would keep all websites/applications run as before. Google intended to change that default to same site equals lax in February 2020. The change would break those applications/websites that rely on third-party/cross-site cookies, but without same-site attribute defined. Given the extensive changes for web developers in COVID-19 circumstances, Google temporarily rolled back the same-site cookie change. Super cookie. A super cookie is a cookie with an origin of a top-level domain or a public suffix. Ordinary cookies, by contrast, have an origin of a specific domain name, such as example.com. Super cookies can be a potential security concern and are therefore often blocked by web browsers. If unblocked by the browser, an attacker in control of a malicious website could set a super cookie and potentially disrupt or impersonate legitimate user requests to another website that shares the same top-level domain or public suffix as the malicious website. For example, a super cookie with an origin of .com could maliciously affect a request made to example.com, even if the cookie did not originate from example.com. This can be used to fake logins or change user information. The public suffix list helps to mitigate the risk that super cookies pose. The public suffix list is a cross-vendor initiative that aims to provide an accurate and up-to-date list of domain name suffixes. Older versions of browsers may not have an up-to-date list, and will therefore be vulnerable to super cookies from certain domains. Other uses. Zombie cookie. A zombie cookie is data and code that has been placed by a web server on a visitor's computer or other device in a hidden location outside the visitor's web browser's dedicated cookie storage location, and that automatically recreates a HTTP cookie as a regular cookie after the original cookie had been deleted. The zombie cookie may be stored in multiple locations, such as Flash Local Shared Object, HTML5 web storage, and other client-side and even server-side locations, and when absence is detected in one of the locations, the missing instance is recreated by the JavaScript code using the data stored in other locations. Cookie wall. A cookie wall pops up on a website and informs the user of the website's cookie usage. It has no reject option, and the website is not accessible without tracking cookies. Structure. A cookie consists of the following components: name, value, 0 or more attributes. Attributes store information such as the cookie's expiration, domain, and flags. Uses. Session management. Cookies were originally introduced to provide a way for users to record items they want to purchase as they navigate throughout a website. Today, however, the contents of a user's shopping cart are usually stored in a database on the server, rather than in a cookie on the client. To keep track of which user is assigned to which shopping cart, the server sends a cookie to the client that contains a unique session identifier. Because cookies are sent to the server with every request the client makes, that session identifier will be sent back to the server every time the user visits a new page on the website, which lets the server know which shopping cart to display to the user. Another popular use of cookies is for logging into websites. When the user visits a website's login page, the web server typically sends the client a cookie containing a unique session identifier. When the user successfully logs in, the server remembers that particular session identifier has been authenticated and grants the user access to its services. Because session cookies only contain a unique session identifier, this makes the amount of personal information that a website can save about each user virtually limitless. The website is not limited to restrictions concerning how large a cookie can be. Session cookies also help to improve page load times, since the amount of information in a session cookie is small and requires little bandwidth. Personalization. Cookies can be used to remember information about the user in order to show relevant content to that user over time. For example, a web server might send a cookie containing the username that was last used to log into a website, so that it may be filled in automatically the next time the user logs in. Many websites use cookies for personalization based on the user's preferences. Users select their preferences by entering them in a web form and submitting the form to the server. The server encodes the preferences in a cookie and sends the cookie back to the browser. This way, every time the user accesses a page on the website, the server can personalize the page according to the user's preferences. For example, the Google search engine once used cookies to allow users to decide how many search results per page they wanted to see. Also, DuckDuckGo uses cookies to allow users to set the viewing preferences like colors of the web page. Tracking. Tracking cookies are used to track users' web browsing habits. This can also be done to some extent by using the IP address of the computer requesting the page or the referrer field of the HTTP request header, but cookies allow for greater precision. This can be demonstrated as follows. If the user requests a page of the site, but the request contains no cookie, the server presumes that this is the first page visited by the user. So the server creates a unique identifier and sends it as a cookie back to the browser together with the requested page. From this point on, the cookie will automatically be sent by the browser to the server every time a new page from the site is requested. The server not only sends the page as usual but also stores the URL of the requested page, the date/time of the request, and the cookie in a log file. By analyzing this log file, it is then possible to find out which pages the user has visited, in what sequence, and for how long. Corporations exploit users' web habits by tracking cookies to collect information about buying habits. The Wall Street Journal found that America's top 50 websites installed an average of 64 pieces of tracking technology onto computers, resulting in a total of 3,180 tracking files. The data can then be collected and sold to bidding corporations. Implementation. Cookies are arbitrary pieces of data, usually chosen and first sent by the web server, and stored on the client computer by the web browser. The browser then sends them back to the server with every request, introducing states into otherwise stateless HTTP transactions. Without cookies, each retrieval of a web page or component of a web page would be an isolated event, largely unrelated to all other page views made by the user on the website. Although cookies are usually set by the web server, they can also be set by the client using a scripting language such as JavaScript. The cookie specifications require that browsers meet the following requirements in order to support cookies. Can support cookies as large as 4096 bytes in size. Can support at least 50 cookies per domain. Can support at least 3000 cookies in total. Setting a cookie. Cookies are set using the setCookie header field, sent in an HTTP response from the web server. This header field instructs the web browser to store the cookie and send it back in future requests to the server. As an example, the browser sends its first HTTP request for the homepage of the www.example.org website. The server responds with two setCookie header fields. The server's HTTP response contains the contents of the website's homepage. But it also instructs the browser to set two cookies. The first, theme, is considered to be a session cookie since it does not have an expires or max age attribute. Session cookies are intended to be deleted by the browser when the browser closes. The second, session token, is considered to be a persistent cookie since it contains an expires attribute, which instructs the browser to delete the cookie at a specific date and time. Next, the browser sends another request to visit the spec HTML page on the website. This request contains a cookie header field, which contains the two cookies that the server instructed the browser to set. This way, the server knows that this HTTP request is related to the previous one. The server would answer by sending the requested page, possibly including more setCookie header fields in the HTTP response in order to instruct the browser to add new cookies, modify existing cookies, or remove existing cookies. To remove a cookie, the server must include a set cookie header field with an expiration date in the past. The value of a cookie may consist of any printable ASCII character excluding end, and with space characters. The name of a cookie excludes the same characters, as well as equals, since that is the delimiter between the name and value. The cookie standard RFC 2965 is more restrictive but not implemented by browsers. The term cookie crumb is sometimes used to refer to a cookie's name-value pair. Cookies can also be set by scripting languages such as JavaScript that run within the browser. In JavaScript, the object document.cookie is used for this purpose. For example, the instruction document.cookie equals temperature equals 20 creates a cookie of name temperature and value 20. Cookie attributes. In addition to a name and value, cookies can also have one or more attributes. Browsers do not include cookie attributes in requests to the server, they only send the cookie's name and value. Cookie attributes are used by browsers to determine when to delete a cookie, block a cookie, or whether to send a cookie to the server. Domain and path. Expires and max age. Secure and HTTP only. Browser settings. Most modern browsers support cookies and allow the user to disable them. The following are common options. To enable or disable cookies completely, so that they are always accepted or always blocked. To view and selectively delete cookies using a cookie manager. To fully wipe all private data, including cookies. Add-on tools for managing cookie permissions also exist. Third-party cookie. Cookies have some important implications for the privacy and anonymity of web users. While cookies are sent only to the server setting them or a server in the same internet domain, a web page may contain images or other components stored on servers in other domains. Cookies that are set during retrieval of these components are called third-party cookies. A third-party cookie belongs to a domain different from the one shown in the address bar. This sort of cookie typically appears when web pages feature content from external websites, such as banner advertisements. This opens up the potential for tracking the user's browsing history and is used by advertisers to serve relevant advertisements to each user. As an example, suppose a user visits www.example.org. This website contains an advertisement from ad.foxytracking.com, which, when downloaded, sets a cookie belonging to the advertisement's domain. Then, the user visits another website, www.foo.com, which also contains an advertisement from ad.foxytracking.com and sets a cookie belonging to that domain. Eventually, both of these cookies will be sent to the advertiser when loading their advertisements or visiting their website. The advertiser can then use these cookies to build up a browsing history of the user across all the websites that have ads from this advertiser, through the use of the HTTP referrer header field. As of 2014, some websites were setting cookies readable for over 100 third-party domains. On average, a single website was setting 10 cookies, with the maximum number of cookies reaching over 800. The older standards for cookies, RFC 2109 and RFC 2965, recommend that browsers should protect user privacy and not allow sharing of cookies between servers by default. However, the newer standard, RFC 6265, explicitly allows user agents to implement whichever third-party cookie policy they wish. Most modern web browsers contain privacy settings that can block third-party cookies, and some now block all third-party cookies by default. As of July 2020, such browsers include Apple Safari, Firefox, and Brave. Safari allows embedded sites to use Storage Access API to request permission to set first-party cookies. In May 2020, Google Chrome introduced new features to block third-party cookies by default in its incognito mode for private browsing, making blocking optional during normal browsing. The same update also added an option to block first-party cookies. Chrome plans to start blocking third-party cookies by default in late 2024. Privacy. The possibility of building a profile of users is a privacy threat, especially when tracking is done across multiple domains using third-party cookies. For this reason, some countries have legislation about cookies. Website operators who do not disclose third-party cookie use to consumers run the risk of harming consumer trust if cookie use is discovered. Having clear disclosure tends to eliminate any negative effects of such cookie discovery. The United States government has set strict rules on setting cookies in 2000 after it was disclosed that the White House Drug Policy Office used cookies to track computer users viewing its online anti-drug advertising. In 2002, privacy activist Daniel Brandt found that the CIA had been leaving persistent cookies on computers that had visited its website. When notified it was violating policy, CIA stated that these cookies were not intentionally set and stopped setting them. On December 25, 2005, Brandt discovered that the National Security Agency had been leaving 2 persistent cookies on visitors' computers due to a software upgrade. After being informed, the NSA immediately disabled the cookies. EU Cookie Directive. In 2002, the European Union launched the Directive on Privacy in Electronic Communications, a policy requiring end users' consent for the placement of cookies, and similar technologies for storing and accessing information on users' equipment. In particular, Article 5 Paragraph 3 mandates that storing technically unnecessary data on a user's computer can only be done if the user is provided information about how this data is used, and the user is given the possibility of denying this storage operation. The directive does not require users to authorize or be provided notice of cookie usage that are functionally required for delivering a service they have requested, for example to retain settings, store login sessions, or remember what is in a user's shopping basket. In 2009, the law was amended by Directive 2009/136/EC, which included a change to Article 5, Paragraph 3. Instead of having an option for users to opt out of cookie storage, the revised directive requires consent to be obtained for cookie storage. The definition of consent is cross-referenced to the definition in European data protection law, firstly the Data Protection Directive 1995 and subsequently the General Data Protection Regulation. As the definition of consent was strengthened in the text of the GDPR, this had the effect of increasing the quality of consent required by those storing and accessing information such as cookies on users' devices. In a case decided under the Data Protection Directive, however, the Court of Justice of the European Union later confirmed, however, that the previous law implied the same strong quality of consent as the current instrument. In addition to the requirement of consent which stems from storing or accessing information on a user's terminal device, the information in many cookies will be considered personal data under the GDPR alone, and will require a legal basis to process. This has been the case since the 1995 Data Protection Directive, which used an identical definition of personal data, although the GDPR in Interpretative Recital 30 clarifies that cookie identifiers are included. While not all data processing under the GDPR requires consent, the characteristics of behavioral advertising mean that it is difficult or impossible to justify under any other ground. Consent under the combination of the GDPR and e-privacy directive has to meet a number of conditions in relation to cookies. It must be freely given and unambiguous. Predict boxes were banned under both the Data Protection Directive 1995 and the GDPR. The GDPR is specific that consent must be as easy to withdraw as to give, meaning that a reject all button must be as easy to access in terms of clicks and visibility as an accept all button. It must be specific and informed, meaning that consent relates to particular purposes for the use of this data, and all organizations seeking to use this consent must be specifically named. The Court of Justice of the European Union has also ruled that consent must be efficient and timely, meaning that it must be gained before cookies are laid and data processing begins instead of afterwards. The industry's response has been largely negative. Robert Bond of the law firm Speechley Bircham describes the effects as far-reaching and incredibly onerous for all UK companies. Simon Davis of Privacy International argues that proper enforcement would destroy the entire industry. However, scholars note that the onerous nature of cookie pop-ups stems from an attempt to continue to operate a business model through convoluted requests that may be incompatible with the GDPR. Academic studies and regulators both describe widespread non-compliance with the law. A study scraping 10,000 UK websites found that only 11.8% of sites adhered to minimal legal requirements, with only 33.4% of websites studied providing a mechanism to reject cookies that was as easy to use as accepting them. A study of 17,000 websites found that 84% of sites breached this criterion, finding additionally that many laid third-party cookies with no notice at all. The UK regulator, the Information Commissioner's Office, stated in 2019 that the industry's transparency and consent framework from the advertising technology group, the Interactive Advertising Bureau, was insufficient to ensure transparency and fair processing of the personal data in question, and therefore also insufficient to provide for free and informed consent, with attendant implications for PECR compliance. Many companies that sell compliance solutions permit them to be configured in manifestly illegal ways, which scholars have noted creates questions around the appropriate allocation of liability. A W3C specification called P3P was proposed for servers to communicate their privacy policy to browsers, allowing automatic, user-configurable handling. However, few websites implement the specification, and the W3C has discontinued work on the specification. Third-party cookies can be blocked by most browsers to increase privacy and reduce tracking by advertising and tracking companies without negatively affecting the user's web experience on all sites. Some sites operate cookie walls, which make access to a site conditional on allowing cookies either technically in a browser, through pressing accept, or both. In 2020, the European Data Protection Board, composed of all EU data protection regulators, stated that cookie walls were illegal. In order for consent to be freely given, access to services and functionalities must not be made conditional on the consent of a user to the storing of information, or gaining of access to information already stored, in the terminal equipment of a user. Many advertising operators have an opt-out option to behavioral advertising, with a generic cookie in the browser, stopping behavioral advertising. However, this is often ineffective against many forms of tracking, such as first-party tracking that is growing in popularity to avoid the impact of browsers blocking third-party cookies. Furthermore, if such a setting is more difficult to place than the acceptance of tracking, it remains in breach of the conditions of the e-privacy directive. Cookie theft and session hijacking. Most websites use cookies as the only identifiers for user sessions, because other methods of identifying web users have limitations and vulnerabilities. If a website uses cookies as session identifiers, attackers can impersonate users' requests by stealing a full set of victims' cookies. From the web server's point of view, a request from an attacker then has the same authentication as the victim's requests, thus the request is performed on behalf of the victim's session. Listed here are various scenarios of cookie theft and user session hijacking that work with websites relying solely on HTTP cookies for user identification. Network eavesdropping. Traffic on a network can be intercepted and read by computers on the network other than the sender and receiver. This traffic includes cookies sent on ordinary unencrypted HTTP sessions. Where network traffic is not encrypted, attackers can therefore read the communications of other users on the network, including HTTP cookies as well as the entire contents of the conversations, for the purpose of a man-in-the-middle attack. An attacker could use intercepted cookies to impersonate a user and perform a malicious task, such as transferring money out of the victim's bank account. This issue can be resolved by securing the communication between the user's computer and the server by employing transport layer security to encrypt the connection. A server can specify the secure flag while setting a cookie, which will cause the browser to send the cookie only over an encrypted channel, such as a TLS connection. Publishing false subdomain, DNS cache poisoning. If an attacker is able to cause a DNS server to cache a fabricated DNS entry, then this could allow the attacker to gain access to a user's cookies. For example, an attacker could use DNS cache poisoning to create a fabricated DNS entry of f12345.www.example.com that points to the IP address of the attacker's server. The attacker can then post an image URL from his own server. Victims reading the attacker's message would download this image from f12345.www.example.com. Since f12345.www.example.com is a subdomain of www.example.com, victims' browsers would submit all example.com related cookies to the attacker's server. If an attacker is able to accomplish this, it is usually the fault of the Internet service providers for not properly securing their DNS servers. However, the severity of this attack can be lessened if the target website uses secure cookies. In this case, the attacker would have the extra challenge of obtaining the target website's TLS certificate from a certificate authority, since secure cookies can only be transmitted over an encrypted connection. Without a matching TLS certificate, victims' browsers would display a warning message about the attacker's invalid certificate, which would help deter users from visiting the attacker's fraudulent website and sending the attacker their cookies. Cross-site scripting, cookie theft. Cookies can also be stolen using a technique called cross-site scripting. This occurs when an attacker takes advantage of a website that allows its users to post unfiltered HTML and JavaScript content. By posting malicious HTML and JavaScript code, the attacker can cause the victim's web browser to send the victim's cookies to a website the attacker controls. As an example, an attacker may post a message on www.example.com with the following link. When another user clicks on this link, the browser executes the piece of code within the onClick attribute, thus replacing the string document.cookie with the list of cookies that are accessible from the current page. As a result, this list of cookies is sent to the attacker.com server. If the attacker's malicious posting is on an HTTPS website https://www.example.com, secure cookies will also be sent to attacker.com in plain text. It is the responsibility of the website developers to filter out such malicious code. Such attacks can be mitigated by using HTTP-only cookies. These cookies will not be accessible by client-side scripting languages like JavaScript, and therefore, the attacker will not be able to gather these cookies. Cross-site scripting, proxy request. In older versions of many browsers, there were security holes in the implementation of the SML Prequest API. This API allows pages to specify a proxy server that would get the reply, and this proxy server is not subject to the same origin policy. For example, a victim is reading an attacker's posting on www.example.com, and the attacker's script is executed in the victim's browser. The script generates a request to www.example.com with the proxy server attacker.com. Since the request is for www.example.com, all example.com cookies will be sent along with the request, but routed through the attacker's proxy server. Hence, the attacker would be able to harvest the victim's cookies. This attack would not work with secure cookies, since they can only be transmitted over HTTPS connections, and the HTTPS protocol dictates end-to-end encryption. In this case, the proxy server would only see the raw, encrypted bytes of the HTTP request. Cross-site request forgery. For example, Bob might be browsing a chat forum where another user, Mallory, has posted a message. Suppose that Mallory has crafted an HTML image element that references an action on Bob's bank's website, e.g. if Bob's bank keeps his authentication information in a cookie, and if the cookie hasn't expired, then the attempt by Bob's browser to load the image will submit the withdrawal form with his cookie, thus authorizing a transaction without Bob's approval. Cookie jacking. Cookie jacking is an attack against Internet Explorer which allows the attacker to steal session cookies of a user by tricking a user into dragging an object across the screen. Microsoft deemed the flaw low risk because of the level of required user interaction, and the necessity of having a user already logged into the website whose cookie is stolen. Despite this, a researcher tried the attack on 150 of their Facebook friends and obtained cookies of 80 of them via social engineering. Drawbacks of cookies. Besides privacy concerns, cookies also have some technical drawbacks. In particular, they do not always accurately identify users, they can be used for security attacks, and they are often at odds with the representational state transfer software architectural style. Inaccurate identification. If more than one browser is used on a computer, each usually has a separate storage area for cookies. Hence, cookies do not identify a person, but a combination of a user account, a computer, and a web browser. Thus, anyone who uses multiple accounts, computers, or browsers has multiple sets of cookies. Likewise, cookies do not differentiate between multiple users who share the same user account, computer, and browser. Alternatives to cookies. Some of the operations that can be done using cookies can also be done using other mechanisms. Authentication and session management. JSON Web Tokens. HTTP authentication. URL. Hidden form fields. Window.name DOM property. Tracking. Tracking cookies are used to track users' web browsing habits. This can also be done to some extent by using the IP address of the computer requesting the page or the referrer field of the HTTP request header, but cookies allow for greater precision. This can be demonstrated as follows. If the user requests a page of the site, but the request contains no cookie, the server presumes that this is the first page visited by the user. So the server creates a unique identifier and sends it as a cookie back to the browser together with the requested page. From this point on, the cookie will automatically be sent by the browser to the server every time a new page from the site is requested. The server not only sends the page as usual but also stores the URL of the requested page, the date/time of the request, and the cookie in a log file. By analyzing this log file, it is then possible to find out which pages the user has visited, in what sequence, and for how long. Corporations exploit users' web habits by tracking cookies to collect information about buying habits. The Wall Street Journal found that America's top 50 websites installed an average of 64 pieces of tracking technology onto computers, resulting in a total of 3,180 tracking files. The data can then be collected and sold to bidding corporations. IP address. E-tag. Browser cache. Browser fingerprint. Web storage. Some web browsers support persistence mechanisms which allow the page to store the information locally for later use. The HTML5 standard includes a JavaScript API called web storage that allows two types of storage: local storage and session storage. Local storage behaves similarly to persistent cookies while session storage behaves similarly to session cookies, except that session storage is tied to an individual tab/Windows lifetime, not to a whole browser session like session cookies. Internet Explorer supports persistent information in the browser's history, in the browser's favorites, in an XML store, or directly within a web page saved to disk. Some web browser plugins include persistence mechanisms as well. For example, Adobe Flash has local shared object and Microsoft Silverlight has isolated storage.